Hello students, today I discuss the questions solution of the previous year question microprocessor and microcontroller. So here first you have to find the objective type questions of 1 marks. So the first question is, what is opcode? So as you all know that the opcode is a portion of machine language instructions that specifies the operation to be performed. For example, add B, move AB. Next is, what is the use of ALE? The ALE is called address/enable, and you know that this is a positive going pulse generated every time the 8085 begins an operation, and it indicates the bits on AD0 to AD7 are the address bits, and this signal is used to latch the low order address from the multiplex bus and generate separate set of 8 address lines, that is A7 to A0. The next question is the microcomputer. What is microcomputer? You can define that it is a small and extensively inexpensive system which includes a microprocessor, memory, input-output devices and user interface. So you have to write in a very brief. Next is, what is microcomputer and microcontroller. So we have already discussed the microcomputer. Next, microcontroller, you can say it is a integrated circuit designed to govern a specific operation in an embedded system, and this single chip have onboard RAM and ROM and peripherals. Okay, so you have to mention this. Next is, what is meant by wait state. So an wait state is a delay experienced by a computer processor when addressing external memory or another device that is slow to respond. We have already discussed this in the class during the programming. Now, how many interrupts does 8085 have mentioned them? Very simple question. You all know that the hardware interrupts, there are 5 interrupts, that is trap, RST 7.5 to RST 5.5 and INTA. And we also know that there are 8 software interrupts in 8085, that is RST 0 to RST 6. Next is, what is memory mapping? So this is very important. So during the study in 8085 architecture, we have already discussed the memory mapped IO and the IO mapped IO. So here simply you can say that it is a mechanism that maps a portion of file or an entire file on disks to a range of addresses within an application's address space, and the application can then access files on disk in the same way it accesses dynamic memory. Next question, that is, what is IO mapping? So you know that a technique used primarily in microprocessing whereby the several devices are interfaced to a processor whose architecture support input and output instructions. Next is, give register organization of 8085. So it is also very simple question. You know that the 8085 has 6 general purpose registers which can store 8-bit data, and these are identified as B, C, D, E, H and L as shown in the, as we have seen in the figure, and they can be combined as the pair also, in register pair also, that is you can use it as 16-bit operation purpose, that is B, C, D and HL. The next question is, what is interfacing? Interface, you know that interface is a path for communication between two components. So interfacing is in two way. You can define interfacing in two way, that is memory interfacing and IO interfacing. So if we can discuss about the memory interfacing, you know that while we execute any instruction, we need the microprocessor to access the memory for reading instruction codes and data stored in the memory. Next is, how can you differentiate, how 8085 differentiates the memory access, that is read or write, or IO access, read or write. So this is very simple question. You know that there is a control signal called IOM signal, and IOM when there is a memory operation, that means it can enable that means it is enabled as low state, and if it is IO operation, it will be enabled as high state. Next, what is status signal? So these signals are used to identify the nature of operation, and these are the 3 control signal and 3 status signal. So you know that the status signals are expressed as S0 and S1. That means while executing any instruction, there is the stages, that is memory fetch, memory read, memory write, opcode fetch, memory read, memory write, or IO read, IO write. So these are the different machine cycle. So the status signal can tells you that whether it's a memory opcode fetch, or whether it's a read operation or write operation. Next is, these are all 5 marks question. The first question is, what is vectored and non-vectored interrupt? So vectored interrupts are those which have a fixed vector address. That means starting address of the subroutine, and after executing this, the program control is transferred to that address. So for example, the trap RST 7.5 to RST 5.5, these are all vector interrupt. And non-vector interrupt, that is not predefined. That means the interacting device gives the address of the subroutine of these interrupts. So here only one interrupt is expressed, that is INTR is expressed as a non-vector interrupt. The next question is, what is masking and why it is required? The masking is preventing the interrupt from disturbing the current program execution. So when the processor performing an important job and its process should not be interrupted, then all the interrupted should be masked or disabled. Next is, what are the operations performed by the ALU of 8085? So as you all know that arithmetic logic unit, which is responsible for performing arithmetic logical operations on data, and it also can perform the operations such as addition, subtraction, logical AND, logical OR, and many more things. The ALU operates on 8-bit data and provides flags to indicate conditions such as 0, carry, sign, and parity. Now the question, which interrupts has highest priority and what is the priority of other interrupts? Very simple question. You have already know that trap interrupt has the highest priority, and next RST 7.5 to RST 5.5 are the next prioritized interrupts. Now where is the ready signal used? Ready signal, where is ready signal? So what is the function of ready signal? The ready signal is used to delay the microprocessor read or write cycle until the slow responding peripheral is ready to send or accept it. So when this signal goes low, the microprocessor waits for an integral number of clock cycle until it goes high. Now we discuss the broad questions, that is these are all 15 marks questions. So very simple question is given. The first question, that is explain the features of 8085 details. During our course of study, we have started with these features basically, and we explained very thoroughly of all these features. You can read from this solution is given, and it is given elaborately. You read out all the points. I don't need to read all these points. You just read this point and memorize it. Next question is, how does the microprocessor differentiates among the positive number and the negative number? So you have already know that the flag registers, that the sign register is the leftmost the leftmost or the most significant bit, which is called the sign bit. That means a positive number or the positive value can be assigned. If the sign is given the 0, then it's a positive value, and if it is a 1, then we can recognize the value is negative. Now the question is given here, the list the components of microprocessor based system. So here in the bracket you can see that single board microcomputer. So the single board microcomputer is basically a complete computer that is built on a single circuit board. So it has the microprocessors, memory, input output and other locations and other features required of a functional computer. So single board computers are commonly made as a demonstration or development system. So here the computer on module is a type of single board computer made to plug into the carrier baseboard or the black pin for the system expansion. So you just read out this and try to understand this. Next is the machine cycle. So during the timing diagram we will see that the function of machine cycle. So it is defined as the time required to complete one operation of accessing memory, input output, or acknowledging an external request. This cycle may consist of 3 to 6 steps, and the 8085 has 5 basic machine cycles, that is load output, read from the memory, write to memory, read IO and write IO. So a simple program is given here, that is write an assembly language to convert 2-digit BCD data to binary data. So here I give an example, that is we take the input 2-digit BCD data as 72. So you know that BCD means binary coded data, decimal. So here 72 means you will see that it is just hex code 0111 and 2 is 0010, and output which is given, that is the binary. That means when you convert the BCD to binary, so the result will be the 48. So here the steps are given and the algo is given, so you have to follow these steps and you can understand, and the program also written here, no need to explain all these things. So I go to the next question, and this is a very fundamental question. They explain the timing diagram in details. So while you draw the timing diagram, the components which are those are very important to draw the timing diagram. So these are the mainly the T state, the control signal, and the status signal. So you have to know all these things, as well as the number of T states can form a machine cycle, and the total and the number of machine cycles can give an instruction cycle. So T state, you can, if I define the T state, it is the one subdivision of the operation performed in one clock period, and these subdivisions are internal states synchronized with the system clock, and each T state is precisely equal to one clock period, and the term T state and clock period are often used synonymously. So you have to understand the definition of T state properly. Next is the machine cycle, the time required to complete one operation of accessing memory, input output, or acknowledging an external request, and this cycle may consist of 3 to 6 T states, and the 8085 has 5 basic machine cycles, that is load output, read from memory, write to memory, read IO, and the write IO. The same question is repeated in the 5 marks question also. And next is the instruction cycle, the time required to complete the execution of an instruction. So it will take number of machine cycle to complete the instruction cycle. Here the most important, that is the components which is required, that is the control signal. Here the control signal are the address latch enable signal, that is ALE, read, write, and IOM. So we have already discussed that ALE should be high when address latch enable is required, that is need to latch the address from the data bus which is multiplexed with the data bus, so address latch enable should be high. And for IOM, whether it's IO operation or memory operation, if it is a memory operation, then the memory signal should be low, and next whether it's the memory read or memory write, for that purpose that either read or write should be low. If it is the read, then read should be the low signal, low giving a low indication, and the write should also giving a low signal. And next is the signal status. So signal status, it is the bidirectional, because it will go up and go down also, because it will give the status of that, whether it's output phase, whether it's memory read or IO read, whether it's memory write or IO write. Next, here already we have exercised in our class, and we have experimented several instruction, and we have drawn the different types of different timing diagram for different instructions. So as we all know that for output phase the 4 T state is required, and for memory read it is 3 state, and for memory write it requires 3 state, another 3 state. For IO read also it requires 3 state, and IO write also 3 state. So here it is given the output phase machine cycle, you just read out, and the timing diagram also given here for output phase machine cycle. The timing diagram for memory read machine cycle also explained here, and you just follow this solution. Memory write memory cycle is also given. I don't need to explain the same thing, because I have already explained. You just read out this, and you know that how to draw the timing diagram. The one instruction is given for which the timing diagram need to be drawn. That is it is the INRM. That is the instruction is given that increment the content of the memory by 1. So how can you draw this timing diagram, and how can you observe that how many T states are required to draw this timing diagram. So here you will see that INR is the output and M is the operand here. So you know that any memory which is pointed by the HL registers, and the content of that memory address location should be incremented by 1. So the common part here is always the output phase operation machine cycle, next is the memory read machine cycle, and next is the memory write machine cycle. So if you follow, then the timing diagram shows that it will require 10 T states to complete the instruction. So the instruction cycle requires 10 T states. And how many machine cycle it require? It require M1, that is for output phase, M2 for memory read, and M3 for memory write. So you have to practice this timing diagram so that you can have better understanding. So everything is written here, and you can read out this and follow it properly. You can draw by yourself. Okay, thank you very much.